everyone. I am Deepika, and I am our project name is topic is automatic tap water system, and my team members are Chandana, Aditya, and Jaikishan. First one, methodology, problem identification. Manual water flow control leads to overflow, wastage, and time consumption. In many places, people manually open and close water taps and motors. If someone forgets to close, our water flow gets wasted and time is also wasted. So automatic system is need to control the water flow. Then requirement analysis. So we collected the required hardware and software. First one, node MCU ESP32IR sensor or ultrasonic sensor. First, it is used to detect the water level in the tank or container. Then relay module, 5V single channel. It works like on off. It is switch controlled by the ESP32. Then 12V solenoid valve, it controls the water flow. And 12V adapter, it powers the solenoid valve. And USB cable plus mobile charger, it is used to power the ESP32 microcontroller. Then jumps wires for making electrical connection. Then many breadboard, it is optional. Temporary testing board for connecting components and resistor, it is used for voltage control if needed. Then hardware implementation. The hardware was assembled using ESP32 microcontroller and it connected to an ultrasonic or IR sensor for a water level detection. ESP32 microcontroller is the brain of the system and sensor it detects the water level. Relay module is connected to the 12V solenoid value and ESP32 was the run and USB power while solenoid wave value needs to separate a 12 wave solenoid value and all components were connected on a breadboard. Then system was checked to ensure accurate sensing and reliable switching. Then testing steps, checking sensor readings for correct water level detection, testing relay switching response on off and verifying solenoid value operation. First one, sensor testing. It verified the sensor detects water level accurately. Then relay testing, check if the relay switches the on off properly. And then solenoid value, ensure the value opens and closes a breadboard on relay response. Then full system testing, it confirm the system performs automatic open and close the value. Then safety and final notes. Never handle wiring while power is connected. Then use fuses on 12V line sized slightly above solenoid current. Avoid touching live wires when power is on. Then use proper fuses with the 12V line to prevent overload. For permanent installation, use PSB instead of breadboard. Then label all wires and for better understanding. Document pin connection clearly in the report. Then next will be continued by Chandana.
Good evening, everyone. I am Chandana. I am going to do implementation ESP32. Instead of Arduino, we used ESP32 in our project because it is a microcontroller which have high performance. Why we can also connect the Wi-Fi or Bluetooth connectivity, and also it is logically works energy efficiency and powerful microcontroller. Instead of Arduino, we use ESP32 because it supports IoT projects. Next, water pump. Water pump, which controls the measure of water flow, and it works on electromechanical device used to move the water from one place to another, and it creates some pressure. If the pressure is created, it will pump the water. It controls the water flow automatically. Next, ultrasonic sensor. Sensor used to measure the distance by sending sound waves or receiving sound waves. Ultrasonic sensor measures the distance using sound waves and also sends the high frequency or low frequency sounds. While touching, the water will be detected in 10 meter, making safe and reliable. In our project, it helps to control the or sense the hands to push the water. Next, single channel. Single channel relay model works on electronic switch. It have low voltage microcontroller and also working controlled by ESP32. It allows the voltage control high voltage device and push the water automatically. The single channel controls only one device at one time. Next, solenoid wave. It controls water flow automatically in pipes. When the electric pipes applied in solenoid wave opens, when the power is off, it will closes. Solenoid wave electrically controlled opens and closes automatically. It allows the flow of water. Next, breadboard. Breadboard is reusable and also without soldering the circuit, we can use the breadboard. Use it to build a test and electronic circuit. It allows quick connection using jumper wires. It helps to testing and modification of circuit during the experiment. It is interconnected and easily connected in wires like components, and also making ideal experimentation like prototyping. Next will be continued by Jai Kishan.
Hello everyone, I am Kishan. Now I am going to explain the system design. So we have created virtually the how our project will work. So I will show in by sharing my screen. So everyone is are seeing this. Is it visible?
Yes.
So here you can see we have used the app called as Oakvi. So we can easily demonstrate the our project IoT. Like we can virtually connect the different devices without manually handling it. So here you can see we have used the ultrasonic sensor ESP32 and a relay module and LED bulb. So altar for LED bulb is tap system. So that here you can see we have given the code. So this is the code which we have generated through ChatGPT, and through this we can easily helps us to know the is that our system will work or not. So here you can see we have connected all the components with the jumping wires. So here if I started stimulation, it will show this here you can see the distance is 400 centimeter, so that it is large amount of distance which cannot detect our hand. So by reducing the distance like 10 centimeter 2 centimeter, here you can see the uh, relay is showing on, that is water on, that is 1 centimeter distance, and the bulb will glow or LED will glow. If I change the distance like 3 centimeter 10 centimeter 8 centimeter, it will the relay will be on. If I increase the distance, the it will close the relay and off the system, so that tap water will not flow overly, and it can control the water flow. So this is the virtually we have created the stimulation. So this is our concept of showing virtually. So that's it. So here you can see there is a system design. Here you can see there is a ESP32 single channel relay and ultrasonic sensor and water pump. So here you can see the connections of everything, every devices each other. So by performing this, we can conclude that we can also stimulate our project in virtually also. The next review we will discuss about how by connecting the hardware devices, by connecting each other with proper manner, and without using our LED light, we will be using the tap water, so that it can easily open the tap water or close the tap system, and it can stimulate the demonstration. So the next concept will be explained by Aditya.
Now I will explain about the result of our simulation. The simulation result shows that the ultrasonic sensor continuously measures the water level of the water level and send the data to the ESP32. When the measured distance is less than 15 centimeter, the ESP32 activates the relay module. As a result, the relay turns on, indicating that the water flow or the pump is on, and this also confirmed by the LED is glowing on. When the distance becomes greater than the 15 centimeter, the relay will automatically turns off, stopping the water flow. This stimulation proves that the system prevents overflow effectively. And next is conclusion. The automatic water flow system successfully control water flow without any human efforts. The ESP32 processor sensor data accurately and operate the relay efficiently. Ultrasonic or the IR sensor detect water level correctly and prevent the overflow. The solenoidal valve opens and closes automatically for smooth water control. The system reduces the water wastage and saves time. Overall, the project is reliable, easy to use, and improves the water management system. Thank you.
So thank you everyone. So this is our project. So at last I will conclude that our project mainly tells us how water system flow and reduces the water usage. We will also be implementing the Wi-Fi and Bluetooth path so that how much water level will be easily calculating and it will show in the interface which will be done later. So this is our topic. If any doubt is there, you can ask me.
What is solenoid valve?
Solenoid wave controls the water flow automatically, man. We use the solenoid wave because control the water flow.
Okay. Why is a breadboard used here?
So to avoid soldering, which contains long process, if we use the breadboard, we can easily cancels out the solid soldering process and alter for that we can use breadboard. So it is a alternate
And
method for
also we can modify the circuit by using breadboard, man.
yes.
That's why.
Okay. Then Deepika, what is the function of ultrasonic sensor?
Ma'am, it helps to control the water flow and it detect the water level in the tank, ma'am.
What is IoT?
So IoT means basic concept like Internet of Things, like by connecting the different devices and ensuring that a proper amount of work is done with proper stimulation, we can easily calculate the work done output so that by using the IoT devices, we can solve the real world problem and enhances the improvements in the daily life. So,
Aditya, what is the main aim of this project?
We can prevent the water loss if and we can prevent the infection spreading by allowing by owning the tap on offing the tap. We can prevent the infection and the high water flow.
Okay. What are the what are the advantages of your system?
so the main advantages is it reduces water wastage. So that you can see in daily life, we use a lot of water, and you can see in public areas and any other bus stand or railway station or taps are normally opened and flow of water will be happening. To avoid this, we can use our project and by calculating the water wastage, we can easily implement in real life world so that it will help for the human beings as well as any other users. So this is our
And also less human effect reduces the manual effect also. And it collects the data that like we can gives advantages.
Okay, what happens if power supply fails?
So yes, ma'am. Actually, there is a need for power supply. We can also alter by using the battery system. Like we can use the separate cells, so that there will be options of two both also. Like a power supply also needed, as well as battery. If one fails, if power supply fails, then the backup there will be a battery. So by using that, it can easily operate the IoT system.
Okay. What type of sensor is a IR sensor?
It is infrared sensor which detects the hands near the tap, and it will allow the open the solenoid valve for the flow of water.
Okay, good. Next, in review 3, what you will do?
So in review 3, we are bringing the hardware components and implementing the hardware components by connecting the
Connecting.
each devices properly and manually, and we are using the water system. We are not using the tap water system, like we are using the stored water at presently. We can implement later in future by using the direct connection of tap water. So in the next review, we'll be doing the hardware component, which we will show manually.
Okay, in that review 3, what are the main components here, hardware components?
ESP32 solenoid wave battery,
Relay module,
adapter,
jumping wires, breadboard,
breadboard and
etc.
resistors.
jumping wires resistors.
Okay. Next, when will you have in the review 3?
After internals, I
After
think.
the
Made
IM.
internals.
Okay, then fine. Let's wind up this session.
Okay.
Thank you.
Thank you.
Mhm.
Listen,
Sir.